Good evening, friends, brothers, and comrades. This is Evermore Alpaca with the third video in my Manned Mission to Eve series. In the first two parts, we got both the Eve lander and the space tug into orbit around Kerbal. We docked them, and we're now ready to make our way over to the purple planet. To calculate what time we should leave, as shown in part 2, I used Transfer Window Planner. You can calculate this on your own or just look it up on the internet, but we're going to use this. You can see we want to leave year 8, day 284, at 2 hours 30 minutes. Don't need to get that precise, but why not? So we're going to put it on super time warp. Even at this speed it will take a while. We can see here the reason it's so important to leave at the right time is we're doing the same Hohmann transfer you use to get to moons, but we just want it to intersect at a tangent with the lower orbit here. To do that, we want to fire prograde when our orbit around Kerbal is facing us retrograde to the motion of Eve. And that'll slow down our velocity relative to the sun, and it'll make us go down. Just like you would transfer in an orbit around Kerbal. Alright, that looks fine to me. So we are going to head on into our tug and lander combination here. And let's plot it out. Transfer window also will tell us. I could have written this down once instead of bringing it up each time, but why not? The other important thing we're looking at is an ejection angle. This tells us where our maneuver node is going to be on Kerbal. If we look at the prograde direction of Kerbal, which is this way, we're looking at 327 degrees from that, so 327 most of the way around. And we're going to want to eject somewhere in here. We can always adjust that a little bit later. Set that target there now while I remember. And drag this out until we see it meet. 160, not bad for just dragging it out there. Let's get it a little closer. $640,000. That's actually pretty solid. Let's try dragging it back and forth a bit. I mean, I didn't bust out a protractor and measure the screen, so I'm guessing I didn't get the ejection angle perfect. And we can see we're down to 20 there. And I just attempted to adjust it and made it a little bit worse. 28. 63. Maybe I should stop meddling when I get it good. 26. I'm okay with that. Let's try dragging this around a little bit. That made it worse. I'm pretty good at making things worse. I'd go so far as to say that's my leading skill in this game. 26. And we can try mucking around with the other vectors here. Some people will try to look at the orbit and figure out what's going to help, but I'd just like mucking around with them, seeing if they do. Plus it's a good opportunity to mess things up, which as specified is my greatest strength. That's making a little headway. You could always do this later in the orbit, but why not? Alright, that's going back up. Okay. I'm alright with that. Alright, so let's get ready for our burn. We got 14 minutes. It's good that we have some extra time here because this is going to be a fairly long burn. We're probably only looking at about 5 meters per second squared here. So this is going to be, as I said, a long burn. When we get closer, we can tap the throttle a little bit to find out exactly how much. Alright, we've fast forwarded. We've fast forwarded towards our ejection burn. I'm estimating that it's going to be about 8 minutes of total burn time, so to center it, we're going to start burning at T-4 minutes. And it's a little over 1,000 meters per second, which means we did a pretty efficient job, because EVE ejection burns are usually around 1,000. And even if we make some errors, there is plenty of leeway, because of all the fuel tanks on the tug and the fact that it's using the nuclear engines. It's very efficient. Obviously not as efficient as an electric propulsion system, but the nuclear engines actually have enough thrust to move large things around in space. I suppose you could make a big stack of the Dawn engines, but that would be ludicrously expensive in a campaign, as well as requiring a bunch of solar power or some kind of approach like that, which I'd rather not bother with. I just want to get this exactly centered. I want to make this burn as efficient as possible. Jebediah is digging it, as always. Alright, we're pretty well centered. Coming up on 4 minutes. And I just realized I did not stage my nuclear engines. Just-in-time staging. And we're burning the long burn to Eve. One problem you can sometimes run into with these long burns, especially from a lower orbit such as this, is your burn, if you're starting it early enough in order to center it around the node, you might actually burn your periapsis under 70 kilometers. We might get close to that here. I don't think we're actually going to do that. But if we do, the air drag in the upper atmosphere isn't so bad. It would be inefficient. It would throw off our maneuver by a bit, but it wouldn't be the end of the world. And you might want to put your patient hats on, because this is going to burn for a while. We'll take a look at how pretty this is. You know what? I'm going to put these solar panels in. These are balanced out by the drill on the other side, but they're probably putting a little bit of torque to that side when they're extended. More so than the drill, I would think. Or who knows, maybe they had it perfectly balanced and I've just mucked it up. You never know. I do like using the Clampetron Seniors, being as they really prevent unnecessary flex in a big dock design such as this. Also helpful for reducing flex is adding extra little structural supports in here. I've got 4 running from the feet up to the lander, well, I should say the return vehicle itself. And there's some others down here too. Oh right, they're from this heat shield to the legs. Being as the heat shield is what's directly connected to the docking port, this prevents it from having to be supported by the rover in there. We don't want to use the rover as a load-bearing member. I guess it isn't load-bearing, it's more torque-bearing. See how we're doing. Yeah, our periapsis is going to be absolutely fine. It's not even going to get close to 70 kilometers. But that is something to be concerned about, especially when you're doing a design like this with the low thrust, high efficiency engines and a significant payload. Again, this would be so much more difficult if we were launching with a lander full of fuel as opposed to mining once we get to the surface. We're reaching the end of our ejection burn. Let's see what our orbit looks like. Got 100 meters per second left to go. And we can see our orbit is finally starting to creep over towards Eve. Now when we have very long burns like this, it's unlikely that it'll be exactly efficient, but we can see how close we've gotten. Alright, looks pretty good. We can just burn a little more and see if it keeps going down. A little over 3 million, that's pretty solid. For kicks and giggles, let's see if we can get that even lower. Alright, we've put our periapsis around 75 kilometers. Incidentally, that's too low. While the lander part of this would love to enter there and just easily fall down, the tug part of this does not want that. I've put it more around 100,000, which looks much more to our liking. One thing we do want to do is still make sure this is an equatorial orbit. So let's drop that down so it looks like we're coming off there more flat. And we're now actually going to impact it, so let's pull that back out a little bit. We're definitely not going to survive litho braking on Eve. Litho braking being a fancy word for slowing down by hitting into it. Though it actually is a real approach if you put those popcorn looking balloon things on it. That gives us both a equatorial looking orbit and an approach just outside of its field, which is exactly what we want. So we're going to do a small burn up here. I do like to get facing the direction I want to go before I time warp, because why not do it when we're not under time crunch? When doing burns far away like this, exactly when you burn isn't as important, but the direction and the duration of the burn become much more important. If we're not going to do this burn accurately, being as this is a correction burn, there's really no reason to do it at all. We might as well just wait if we're not going to do this carefully. And the time, as I said, the time we do this is not super critical, so I'm going to do this whenever I feel like it's lined up and not rotating around anymore. Let's move down towards it. As I said, we've got plenty of time to do this. The exact time that we do the burn at is not critical, being as we're so far away. The reason it's wobbling around is because of the wobble of the spacecraft. It's not quite sure where we're actually pointing. It's doing its best to estimate. Alright, let's see what that looks like. Somewhere in the area. It's wobbling around a bit as we wobble. So let's just warp on a little farther over there. Poor Jebediah all alone for about 15 weeks there. He's having a nice trip, I hope. And we can see Eve being on the inside of us. It is catching up to us as we approach. Time warp complete. I time warped a little bit out because I've had some issues with time warping from a long ways away. Where it decides it's just gonna... Actually, let's slow that down here. Look at that. Our Eve periapsis is a little bit closer than it was estimating when we were farther out, so let's pick something a little ways away. Let's correct that. There is a RTG, which is the radioisotope thermonuclear generator, somewhere in this build, which is why I'm not very concerned with keeping the solar panels out. Excellent. Let's time warp up to our Eve encounter. Warp here. I can't recall off the top of my head if I've done the Eve science experiments for the in space above Eve, so we'll just take a look when we get there, because we can. Yeah, I'm not entirely sure I remembered to put the mystery goo packs on this thing. That would have been something to remember for next time. I'm trying to click the Science Junior here. I guess we'll have to go around to the side. I'll be a little bit miffed if I forgot the mystery goo experiments, but what are you going to do? I also should have brought a scientist. I'm getting forgetful in my old age. Only scientists can restore inoperable modules. Which I'm not too worried about, because I've already unlocked a tech tree in this. It's just a little bit irritating. What do you know, guys? I knew I'd forget something. Always a next time. Now approaching Eve here after having done some quick experimentation. We're not exactly at equatorial. We do want to go for an equatorial orbit, so let's make that happen. Well, it looks pretty solid. It doesn't have to be exact since we're going to be doing a big long burn later. Exactness will not be that important. But let's try to get it a little closer. That looks pretty good to me. Overshot the node by a bit, but shouldn't matter that much. It's not super critical we land exactly on the equator or anything. Just has to be in the ballpark. Swapped locations so they're about equal. And this is going to be a big old burn. There will definitely be some editing for this because I doubt you guys want to sit here and watch me burn for minutes and minutes. So let's get facing in the right direction. Luckily, this thing has plenty of fuel. We're not going to get close to running it out. One approach you can do is if you're not too worried about where you can land, you can of course just go for the direct approach and go with your lander and just try to land, but if you don't get into a stable orbit first, it's just harder to pick out a good landing spot. And we will need to pick a landing spot for this. I think we're going to need an altitude of at least 1,500 meters above sea level to get off of Eve, and relatively flat, not an ocean. So I'd like to be able to pick a spot. We'll pick somewhere mountainous and then try to find somewhere flat in the mountains. Hopefully that won't be a contradiction. So it's estimating a little over 10 minutes, so we're going to wait till a little over 5 out. And I will see you guys on the other side, and we'll see what our orbit looks like. We are approaching the end of our very, very long burn here. I went into the kitchen and made myself a sandwich while it was burning away. Timing was pretty solid. Came back, we had a little over 100 meters per second left. And look at that, we got the sunrise over Eve, I think. No, sun's over there. That makes sense because this is the light side. I guess it's got some kind of halo, maybe from the gas in it. I'm not entirely sure. We need an evologist to explain this. We're almost done with our burn here. It's not critical that we are in a particular orbit. As we have plenty of extra delta V in the tug, we can make any adjustments that we need. But this looks close enough to the equator. We don't want to fall down on this side of the planet, which is relatively flat. It's the lowlands. We want to be falling down on these mountains over here. Now there is some ocean as well in here. We'll have to make sure we miss that. We can use the air brakes, turn the air brakes off and on to fine-tune our landing location as we're coming down. But that does only give us a limited amount of control. Making sure we drop in at the right spot is very important. I'm going to fine-tune that a bit. I'm aiming for that saddle of land between the two seas there. There's the bay on the one side and the sea on the other. So we're going to try to land right in there. There's some decent elevation. It's more or less flat. At least flat enough that we can land on it without tipping over. A tip over would be the end of this mission. We have no way to right ourselves. But we have a very wide base with the heat shields on the outside, so, and being as the lander is lighter than it looks, so as long as it's not too bad of a slope, we should be alright. Now since the lander is unpowered, we're going to use the tug. We're going to drop the whole assembly into suborbital. And then since we need to keep the tug is going to separate, and we're going to do a short prograde burn and put it back into a full orbit. Once we have the tug back in prograde, we can stop worrying about that. We can switch back over to the lander, and we will go through the process of landing that. One thing we will have to remember to do is the docking port on the lander needs to be separated because it's actually below the heat shields. I suppose it'd be alright if we left it on there, but it might not actually burn off since we did a very long insertion burn, and our orbital speed around Eve is not that great. And if we still had the docking port in the bottom, that would probably make us tip over, unless we landed somewhere completely flat, which is not going to happen because we need elevation. So we're just going to rotate this around and then do a short prograde burn. We just need to get the periapsis up over 90 kilometers. This is our ticket home. So if we care about Jebediah, which I hope you do, we'll definitely need to save this. And I have just over-rotated this. Let's pull it back. Doesn't need to be exact, just burn enough to get over 90 kilometers, and we are good. All right, we're gonna sacrifice the decoupler and docking port to the gods here. And then we have a little bit of time to wait before we actually drop into Eve's atmosphere. I'm going to fast forward through a little bit of this. And we're now dropping in, so we better get turned retrograde as quickly as possible. And I'm going to also fast forward through some of this. We're going to have a lot of time just falling through Eve's atmosphere. It is even deeper of an atmosphere than Kerbin's, so this process will take a little while. One thing we do want to do is keep an eye on what our landing spot looks like while we're coming down. It looks like we're probably going to overshoot what we're aiming for, so I'm going to just leave the brakes on probably the whole time. That mountain there would be the optimal spot to land, but I think we will overshoot it even if I leave the brakes on the whole time. And that looks all right. We've overshot the big mountain there, but we can see on Kerbal Flight Engineer we still have good elevation on this terrain, more than enough elevation to return. No reason not to put the parachutes out now while we're thinking about it. And we're going to drop the rest of the way down here. A lot of fast forwarding in here. The one thing that remains to be seen is, are we going to land somewhere with acceptable slope? This area looks relatively flat. There's a little bit of a slope, but I think we'll have no issue landing on this without tipping over. Also, make sure when you actually touch down that you have physics warp all the way off. If you have physics warp on at all, it's very likely to fall apart as you hit the ground, even if the impact is well within what you should be able to land at. So we're going to put this at 1x, and the moment of truth. Oh, this is almost entirely flat. We'll be fine. All right, guys, pop the champagne, release the balloons. We are good. This has been part 3 of Evermore Alpaca's Manned Mission to Eve series. In part 4, we will do some science on the surface of Eve and then return to orbit. Thank you for watching. Leave any comments below.